One of the things that becomes really helpful is determining how long a backup generator, a battery, something like that is going to last. So, based on the size of it, based on how many chemicals it has inside, so it can keep moving those electrons from one terminal to the other, there's a limit as to how long one of these will last before we either need to get a new one, recharge it, so on and so forth. So the way we actually determine that is with a unit that's called the amp hour. You can see here, let's say we bought this battery on Amazon, and let's say in this made up example, we're going camping, we want to hook this up to a light bulb or some kind of like lantern. How long will it last? That would be good to know so we know whether we need one of these, two of these, so on and so forth. So the way we use the unit of the amp hour, as you can see here, this is a 6-volt battery, so we'll provide 6 volts between the positive and negative terminal, and this 36 amp hour is indicative of how long this will last. So what that actually winds up meaning is that this battery is capable of giving you 36 amps of current for 1 hour, depending on what you set that up to, what circuit you connect it to. So to actually look at the analyzing the actual capacity, if I took this 36 amp hour battery and I connected it to a light bulb that drew 36 amps of current, well, that's going to last for 1 hour. And hopefully that makes sense. If it's 36 amp hours, well, that means it's capable of providing 36 amps every hour or within 1 hour. So what would happen then if instead of plugging it into a lamp that pulled in 36 amps, what if it was a weaker bulb and it only pulled 18 amps? So it's that same 36 amp hour battery, but if it's connected to a circuit that's only drawing 18, how do I figure out the time that that would last for? Well, it's actually very simple. If you look at the units, if I have amp hours and I want to just get hours, I need to divide by amps. So if this is a 36 amp hour capacity battery and it's only connected to a circuit that draws 18 amps, well, if I divide the 36 amp hours by the 18 amps that this specific circuit is actually drawing, you find that you're left with 2 hours. And it makes sense if you kind of take a step back. If a 36 amp hour battery will last 1 hour in a circuit that's drawing 36, well, in a circuit that draws half the current, you would expect that to last twice as long. What if it's a more realistic example? You're not really going to be hooking up batteries that draw 36 or even 18 amps of current. That's kind of a large amount of current. What if I connect it to a small battery, such as the one that we might want to go camping with, and it only draws about half an amp, which is actually still pretty high for just one light bulb, but we'll assume that this lantern draws about zero point 0.5. Well, the same thing applies. If I want to know how long that lasts, I take the 36 amp hour capacity. If I divide it by the zero point 0.5 amps that I have determined that this bulb or this circuit is going to draw, well, I can find that this should last for roughly 72 hours. It's not an exact calculation. There's some other things that are play here, but we can expect to get about 72 hours or about 3 days off of this battery. So if we were going camping and this was the bulb we had, so long as we're not going camping for more than like a weekend, one battery is fine. If we're going to be going for longer than a few days, you're going to want to bring a second or even possibly a third backup battery. If we want to look at a more mathematical example or a more comprehensive example, we could take a look at this. So if I happen to have a 12-volt battery with a 72 amp hour capacity, and I hook it up to a bulb that has a resistance of 8 ohms, I ultimately want to know how long will this battery last before I need to replace it. So if we list everything we're given, well, we know the voltage is a 12-volt battery. We know that the resistance of the circuit that it's connected to is 8 ohms. And the capacity of that voltage source is 72 amp hours. If we slide back up to the top, we know the one thing we pretty much need to figure this out is the current that the circuit we're hooking this battery up to is actually drawing or is actually pulling. So that would be a good place to start. If I have the voltage and the resistance, Ohm's Law will allow me to calculate the current, and I can find that a 12-volt battery hooked up to an 8-ohm circuit will generate 1.5 amps of current. Once I have that value, it's simply a matter of dividing the capacity by the actual current that's being drawn, and in this case, I will find that this specific bulb should last for about 48 hours. I apologize. The battery should last for about 48 hours before this bulb will start to get dimmer and eventually go out. At that point, I would need to either recharge the battery or get another one, and if it was the same battery, I would get another 48 hours. So the important thing to realize here is I essentially need to figure out the current that my circuit is drawing, and then I'm able to use the capacity and divide that by the current that's being drawn to figure out the total amount of time that that battery, that generator will last.